All right, we are going to go over graphing inequalities and solving compound inequalities, and it's going to be a fun time. So we're just going to start off reviewing the basics of graphing an inequality. So there's two things, or maybe more than two things. Let's not oversimplify this. What matters when we go to graph an inequality is we want the letter to be on the left side. Now, in these examples that I've given, the letter M on the first three and N on the last one is on the left side, which is going to help us graph it. So we care that the letters on the left, the numbers on the right, and if that's the case, then we can actually use our inequality like it's an arrow pointing us which direction we want to graph. The other thing we have to pay attention to is whether it's equal to or not. So on number 1, M is less than -3. It's not equal to -3. So at -3, we're going to draw an open circle that is not filled in, like so. And then we're going to say, well, where are the numbers that are less than -3? Since that's what our inequality is saying, those numbers are to the left. They're the more negative numbers. So we're going to shade to the left. And some teachers will have us shade like a line, like make our line go up like this to make it more obvious. I personally am like, as long as it's obvious which direction you shaded, I don't really care how you shade, but it does matter that we show which direction we want our line to go. So it was an open circle because there's not a line underneath. So that would be like in this one where we have a line underneath. That's going to make us do something different. It's an open circle and it is to the left. On number 2, M is greater than 5. And so that means that I will put an open circle at 5 because it's not equal to. Then I'm going to draw to the right. So I said this earlier, but I didn't necessarily put it out on number 1. We actually can pretend like this is an arrow pointing us which direction we want to shade. So it's like an arrowhead pointing to the right. It's going to help us remember which direction to shade. But also, if we just think about it, if M has to be bigger than 5, where are the numbers that are bigger than 5? They are to the right. So now that means I put a filled in circle at -2. And then I have to say, okay, which way am I shading? If I think of it like an arrow, then that arrow is pointing to the left. Or if I think, where are my numbers less than -2? That also is to the left. So I'm going to shade to the left. And then on 4, it's greater than or equal to. So that means that my dot is filled in. And I can think of this like an arrow pointing to the right, where I can think, where are the numbers that are bigger than -6? Those are to the right. So that's just if we have a really simple inequality that we're just wanting to graph. But guess what? A lot of times they want us to solve the inequality first and then graph. So let's look at some 1, maybe 2-step inequalities. We're supposed to solve it and graph its solution. Now that means that there's 2 parts to my answer. Part of my answer is an inequality, and part of my answer is the graph. So this is going to work the same way that solving equations would work. So p over 8 is greater than 3. If that was an equal sign, I would say, let me move that 8 so that p is by itself. So we're going to do the same thing even though it's not an equal sign. To get rid of an 8 on bottom, the easiest thing to do is times by 8 on both sides so that we get p is greater than 24. The greater than symbol that we had right here stays a greater than symbol, and that's the first part of our answer is actually that p is greater than 24. To draw that on our number line, we go to 24 and we put an open circle, and then we say, which way should I shade? Looks like it's pointing to the right, so I'm going to shade to the right. Now, there is one thing to solving inequalities that doesn't happen with an equal sign. If in our solving we either multiply or divide by a negative number, we have to make the inequality face the other way. So think about solving this for n. I'm going to have to divide by -4. And because I divided by -4, I'm not going to change it to an m. I'm going to say that this is in, and I'm going to flip the inequality around. Right now it's a less than. It needs to flip and be a greater than. 8 divided by -4 is -2. There's a whole reason behind that that has to do with the fact that the negative in front of this letter is causing the opposite numbers that we would think to actually work. And so it's kind of difficult maybe to get in our heads why that's the case, but it is the case that we have to do it. So it's really, if nothing else, a rule we need to memorize. If I divide by a negative, and what matters is that it's by a negative, not the top number here, but the bottom number, that's causing me to flip the inequality. So I'm going to put an open circle at -2, and it shades to the right. On 7, I'm going to say, how do I get a by itself? Well, why don't I just add that 7 over to the left side? So that's 3 is greater than a. Now that trick we have that helps us graph things by looking at which direction the inequality is pointing doesn't work unless a is on the left side. So we've got two choices. Either we can try to reason out in our head which direction to shade, or we can just flip the inequality around. Flipping it means that I make a be on the left and 3 be on the right, and that makes the inequality face the other direction, because over here in my inequality, the smaller side is pointing to a, so if I flip it around, the smaller side still needs to point towards a. So we're saying that our solution is all of the numbers less than 3. So I'm going to put an open circle at 3 and shade to the left. And that's my answer. You could get there from here if you're reasoning it out. If you're saying in your head, if you're trying to think about either if you read it backwards and say a is less than 3 in your head and then graph it, or if you're saying, well, if 3 is greater than a, then that means I have to shade everything that's below a. That's fine. You just have to come up with some way that you yourself can reliably shade the correct direction. On 8, we're going to subtract 5 from both sides. Get n is less than -6. So I'm going to put an open circle at -6, and I'm going to shade to the left. And that's it. Now those were all one-step inequalities because we just did one thing basically to get rid of what was around our variable. Let's see how we do with, I don't actually know what's next. Oh, two-step inequalities. So go figure. These are two-step or maybe even slightly more than two-step. We'll find out together. So the thing here is that we want to, wow, all of these have the variable on the right side. That was not intentional on my part, but we'll just go with it. So on 9, we want to solve this for k. And sometimes we forget the way to start a problem like this. But if there is a fraction where everything on one side is a fraction, all we have to do is multiply by what's on the bottom of that fraction. So multiply by 2 over 1 on both sides. And that will actually get rid of our fraction. So it's like we're moving the 2 to the other side in a way. So -4 is less than -4 plus k. Actually, any point along the way here, we could flip this inequality around. If I know that at the end of it, I want k to be on the left, I could go ahead right now if I wanted to and rewrite this as -4 plus k is greater than -4. I took this and wrote it first, this and wrote it second, and then I flipped the inequality around. You can do that at any point along the way. Just don't do it while you're doing a different step because you might mess it up. Then I'm going to add 4 to both sides, which means that k is greater than 0. So I'm going to put an open circle at 0 and then shade to the right. And that's my solution and my graph. On 10, This time it's not all one fraction, so I don't want to multiply by 2 first. I have to before I can do anything else. Because if I multiply by 2, technically I'd have to multiply everything by 2. I'd have to multiply everything I have by 2. And that's fine if we want to do that. In fact, since I already wrote it down and I'm lazy, maybe, no, I'm just kidding. I'll go ahead and erase it and do it the way that we should actually probably prefer to do it. Anyway, doesn't really matter which way. Okay, so what we should think when we see this is, okay, that -5 is not attached to my fraction, so I can move that by adding it over. That gives me -5 is greater than or equal to b over 2. Then I'm going to times both sides by 2. Now, I'm multiplying by a positive number. Even though this is negative, what I multiplied by to solve is positive. So I don't need to flip the sign because of that. But now I need to flip it if I'm going to use my trick to graph. So I'm going to write the v on the left, the -10 on the right, and then switch which direction the inequality is going. So -10 is going to the left. Let's see. I did a bad job of picking these as far as having one that divides by a negative, but oh well. 11. This one is more like what most of our two-step equations are like. We're going to add 3 and get -14 is less than or equal to 2r, then divide by 2. We didn't divide by a negative, so it's -7 is less than or equal to r. We're going to flip it around, so r is greater than or equal to -7. So -7 is here. Let's build in circle. We're going to go to the right. 12, we have two options. We can distribute, or we can divide this 5 over since it divides evenly into -50. But if you're feeling like that's a weird idea, we'll just distribute and see what happens. -50 is less than -25. I'm going to add 25 over and get -25 is less than 5p. Divide by 5. What I'm dividing by is positive, so I don't flip the inequality for that, but I do flip it because I want p to be on the left. So p is greater than -5. So I put an open circle and I go to the right, like so. Okay, our last section, or last set of stuff that I want to talk about in this video is compound inequalities. A compound inequality is an inequality that has two inequalities, and it involves an and statement or an or statement that connects them, or it may just not say anything. For instance, 13, this is actually an and statement, even though it doesn't use the word and. It's an and statement because they combine this into one inequality. So what we want to do is we want to look at the middle of this inequality, and we want to say, if I was in an equation or whatever, and I had 9 plus p and I wanted p by itself, what would I do to get that? I would subtract 9 from both sides of my equation. Well, we have an inequality, we actually have two inequalities. So what we're going to do is we want to subtract 9 from the middle, but in order to do that, we also have to subtract it on the left side and the right side. So this is kind of a weird situation. Equations only have two sides, so we do everything to both sides. This is technically something that has 3 different parts, so we're going to do it to each of the parts, the left, the middle, and the right. That gives us 1 minus 9, which is -8. Less than or equal to p, which is less than 0. What this is saying is that p has to be between -8 and 0. So that's where we're going to shade on our graph is -8 is between -8 and 0. But also, we have to look at our inequality symbols to know what kind of dots to do. Since -8 is next to an equal to, it needs to be filled in. And since 0 is next to a not equal to, it should not be filled in. We're saying P is between those, so we're going to shade in between those two numbers like this. So anytime we have an and, or a situation like this where it's like we have two inequalities combined into one, we should end up shading in between. Like that's something that we can rely on, that it should happen. If we have an or statement, like on 14, the opposite's going to happen. So I'm going to solve these separately. Think of this like it's dividing this into two problems. So I need to subtract 3 to solve this first one. K is less than 0. We're going to multiply by 6 in the second one because we've got a fraction that we want to get rid of. So we get K is greater than or equal to 6. Neither of those did anything that would make me flip an inequality. So our answer, our solution is K is less than 0 or K is greater than or equal to 6. Well, if I graph those, I find that one of them goes to the left and the other one is going to the right, but they're doing that in such a way that they're going away from each other. And that's what should happen anytime that we have an or statement, is that they should be going the opposite direction from each other. So and is between, or is out. And you can remember that because or and out both start with the letter O. So same kind of deal on 15 and 16. 15 says and, so it's even more clear than 13 was. We're going to times by 3 and get that P is less than or equal to 6. And we're going to divide by -7. We're going to go, aha, I divided by a negative. That makes me flip the inequality. I don't know why I wrote it up there. So P is greater than or equal to 5 and P is less than or equal to 6. That means both of those are filled in circles because they're both equal to's. They both have a line underneath. Less than or equal to 6, greater than or equal to 5 is just this itty bitty space in between. And so this is where I would remind you that at this point in our praying about whole numbers. So if you're thinking, okay, so the answer can be 5 or 6. Well, it can be 5 or 6 or any of the decimals in between. There's actually an infinite set of numbers between 5 and 6 that work for this solution. So, yeah. 16 is an or, so they should face out. On this first one, we're going to add 1 to both sides and get x is less than or equal to 5. Then on the second one, we're going to subtract 6 and get x is greater than or equal to 7. So x is less than or equal to 5. That points this way and is greater than or equal to 7. So that points this way. And then we're done. So the things that you want to, like if you're doing a quiz or an assignment or whatever, you want to check maybe after you're done and look at your inequalities and check that you have filled in circles for your equal to's, whichever way, that you have hollow circles for your non-equal to's. You want to check that you remember to put the variables on the left so that you can treat the inequality like it's pointing the direction you want to shade. So x is less than something means shade to the left. X is greater than something means shade to the right. But that only works if it's on the left side. And you also want to check and make sure that if you divide by a negative or multiply, but multiplying happens a lot less often. But if you do either of those things, you flip the inequality so that it's facing the other direction. So if it's less than and you divide by a negative, it turns into greater than. It does not affect whether or not it's equal to. So they should either both, like you should always have equal to as you're going through, or you should not have equal to when you're going through. There's nothing that we do mathematically that would change it from an equal to a not equal to that I know of. And I know a lot of math. So yeah. All right, well, that has been Inequalities. Thanks for watching.